Well, it's better to stay near the receiver so people can hear you. When you are moving, you can hear you.
So Stefano will tell us about Bohr and epistemological lesson of quantum mechanics. Okay, so thank you very much for the invitation, and now I have to say after Olival's talk that I understand why my talk was scheduled after this, because I guess it will provide a perfect, strong evidence in support of his thesis that philosopher of science have not really contributed any relevant insight to this debate, however. So let me start with this quotation from Bohr. In the system to which the quantum mechanical formula is applied, it is of course possible to include any intermediate auxiliary agency employed in the measurement process. This is purely a matter of practical convenience, just as in classical physical measurements. The only significant point is that in each case some ultimate measuring instruments must always be described entirely on classical lines and consequently kept outside the system subject to quantum mechanical treatment. This is one version of Bohr's infamous account of measurement, which is arguably the most controversial aspect of a doctrine which is itself not exactly famous for its clarity. And what I want to suggest here is an interpretation of this account based on a particular construction of Bohr's philosophy of language. So first point, why is the account problematic, which I think is something everybody will agree with. And second point, why the philosophy of language. So let me apologize, I will have to read, otherwise it will take too long. So the fact that the account is problematic or even untenable is a kind of commonplace. In a sense, Bohr's story is trivially correct, since it just describes what physicists do in practice. However, the problem arises when one tries to formalize this account, because then one is presented with the dilemma between denying the universality of quantum mechanics or deriving the classicality of measuring instruments from their quantum description. And this dilemma seems to be something that Bohr just ignores. To the frustration of his critics, who typically portrayed Bohr as being dogmatically committed to one or the other solution, as a matter of fact, he refrained from clearly endorsing either alternative. And this is, I think, an important clue that indicates that the very formulation of the problem that he had in mind was not exactly what is usually understood by the measurement problem. Another clue that this must be so is provided by the passages like this one. Here Bohr seems to imply that physics is kind of accountable to communication, not the other way around. In other words, we have a reversal of the ordinary view according to which the task of language is to passively represent the physical world. And here it becomes pretty clear that we have already taken some steps into the territory of the philosophy of language, and so I turn to that. is wrong to think that the task of physics is to find out how nature is. Quantum physics is about what we can say about nature. This is a very, very well-known quotation from Bohr, which was reported by O. Peterson, who was his assistant, that we have seen in the 50s. And as is often the case with Bohr's aphorisms, it is not immediately evident that the sentence does not express a platitude. In this case, just an exhortation to accept the completeness of quantum mechanics, in the sense that quantum mechanics would be giving us all that we can expect from theory, given our epistemic limitations. So essentially a plea for instrumentalism, with perhaps a counter flavor in the emphasis on the subject of cognition, because what we can say. So it's we. Now, my view is that what Bohr had in mind here was possibly something quite different from a generic, pretty innocuous methodological recommendation for quietism. What his statement presupposes, I think, is a much more radical, structured, and far-reaching reflection upon what should count as rational practice in general, not just in physics. And I think his analysis of objectivity, hence in particular the notion of complementarity, should be understood within the framework of this general reflection on rationality. The idea that quantum physics may help us elucidate the way in which we use our words is a refrain in Bohr's writings. Here I have reported a few samples. I guess most of you are familiar with this. And it is quite telling that Bohr contrasted this kind of analysis. So we can just read one. Another situation with which quantum physics presents us demanded a renewed analysis of the presupposition for the application of concepts used for orientation in our surroundings. I think it is quite telling that Bohr contrasted this kind of analysis to what would be a more natural approach. One that, for example, Schrödinger defended in his correspondence with Bohr, where he wonders why, in view of atomic phenomena, we could not simply replace the concepts we are familiar with by new concepts whose meanings would arguably better match the objects that atomic physics present to us. And Bohr, I think, is clearly opposed, not I think, he says clearly once that he is opposed to this strategy. And as in other cases, one could interpret this as just an expression of a conservative instrumentalist attitude. Something like, we don't need to change our concepts in order to deal with quantum phenomena. All we have to do is to be more careful when we state the truth conditions of the empirical claims that we make about atomic objects. This way we can avoid mistakes, like, for example, claiming that we have to do with a particle in a situation in which, in fact, we are dealing with a weight, for example. Now, I think that this is not, or at least not entirely, Bohr's point. What is at stake is not just the meaning of specific terms or expressions, as it is the very idea that meaning understood in terms of truth conditions is what can explain the rules that govern linguistic game. So, actually, I think what Bohr is putting into question is this idea that meaning understood in terms of truth condition can explain the rules that govern, for example, experimental practice of quantum mechanics. Okay. So typical instance of this traditional semantic order of explanation that I think Bohr refuses is provided by formally valid inferences, in which we are expected to endorse the conclusion of the inference if we endorse the premise, because the truth conditions of the premise are contained in the truth condition of the conclusion. So, Bohr does not think that the norms that are implicit in the quantum game can and need be explained by a model based on truth conditions. Such norms, such rules, can be made explicit by means of conditional statements, in which both the antecedent and the consequent are themselves conditional statements. That is, they are statements which assign a probability distribution conditioned upon the performance of a specific measure. In this way, we end up with something like a grammar for the ascription of values to observables, and this grammar, again, could, but need not, and indeed does not, suit a truth condition semantics for value ascriptions, at least not in any straightforward way. Okay, now the point that I want to make is that Bohr's reflection, as I have briefly reconstructed it here, comes astonishingly close to the ideas that were emerging in the very same years from the work of philosophers like Wittgenstein and Carnap. And indeed, the epistemological issues that Wittgenstein and Carnap were struggling with present deep analogies with those raised by quantum mechanics as Bohr understood them, in my opinion. The work of Wittgenstein eventually resulted in a major paradigm shift, which Alberto Coffa, in his classic historical reconstruction of the semantic tradition in philosophy, has compared to Kant's Copernican turn in metaphysics. From this paradigm shift, an entirely new way of conceiving the relationship between the constitution of meaning and the foundation of knowledge emerged. So here is a quotation which I think is quite relevant from Coffa, and I think it's worth reading. The semantic explanatory route does not go from objects or meanings to the, he is describing here this paradigm shift that in his view was somehow fostered by Wittgenstein's work. The semantic explanatory route does not go from objects or meanings to the laws concerning them and then to our reasonable linguistic behavior. But it goes the other way around, from the linguistic behavior, from our linguistic behavior to meanings. The ultimate explanatory level in semantics is not given by references to the form of objects or meanings, but by reference to the meaning-giving activity of human beings, an activity embodied in the endorsement of rules. And I just want to add one remark here. Suppose we accept the idea that the rational justification of the rules that we follow in practice, including scientific practice, that this rational justification does not require semantic machinery involving truth. I want to stress that this does not mean that there cannot be portions of the language in which truth does play its usual role, in particular in connection with objectivity. So, with these remarks in mind, we can go back to what Bohr thinks quantum mechanics is about. So I return to the previous quotation. Quantum physics is about what we can say about nature. And what I want to suggest here is that the phrase what we can say in this quotation is not meant to refer to a set of truths that our epistemic means allow us to establish concerning atoms, molecules, etc. Rather, the phrase refers to the rules that govern the practice and therefore constitute the content of empirical claims, and in this sense determine what can meaningfully be said. In other words, the task of quantum mechanics, what the theory is about, is the delimitation of objective thought. Okay. Having said all this, the question now is, why should the physicist have concerned himself with such philosophical issues? I mean, Bohr did not regard this as a relation devoid of scientific implication. It was not just his hobby. On the contrary, as we other people stress today, he viewed this problem as a central and essential contribution to his scientific field. So the question is, why? And so I think every Bohr scholar has to address this question, and the answer that I want to pose is that I think Bohr quite soon realized that atomic physics had uncovered a problem whose nature was not physical, but distinctly semantical. And I think Bohr came to this conclusion because he saw more clearly than others that the uncertainty relations could not have an epistemic character. They could not straightforwardly be taken to quantify our ignorance about the actual value of an observable, insofar as, in general, quantum observables cannot be thought to have a value. Thus, for example, in general, the assertion that a particle has a certain position does not have a well-defined truth value. And in this sense, it is not objective. Or, as Bohr would have put it, it is not unambiguous. This was his term. That a particle has a position only qualifies as a meaningful assertion in certain contexts. And Bohr thinks that this contextuality is intrinsic. It cannot be reduced to more familiar forms of contextuality, like, for example, the value of a contextual variable can be traced to the interaction of two non-contextual variables which provide a description of the context. Okay. If this is so, sorry. No problem. Yes. So if this is so, that is, if the proposition that ascribes values to physical observables cannot, in general, be assigned a truth value, we cannot tell whether they are true or false. I mean, it doesn't make sense to assign it a truth value. Then it's difficult to see how truth could provide a foundation for the prescriptions. The prescriptions that the theory gives us, in the same way that I described previously, using the model of valid, formally valid inferences. To be sure, truth continues, as I stressed, to play a role in linguistic practice, particularly when it comes to distinguishing subjective attitudes from objective claims. So, for example, when I tell you that your belief that the particle has a certain position is not true. In this case, we have a kind of interplay between subjective attitude and objective claims, and true enters the game. However, the rationality of the prescriptions cannot be explained by the way in which the truth values of empirical claims happen to be distributed across possible worlds, as in standard semantics. Given the situation, one can try to change the physics and metaphysics in order to save the traditional semantic order of explanation, which, remember, goes from truth to rules. Or one can choose, as I think Bohr did, more or less explicitly, one can choose to reverse the order of explanation. The prescriptions, in particular those that derive from the uncertainty relations, become primitive. And the linguistic notion of truth is taken to emerge from the structure of the prescriptions rather than grounding it. Okay. So let us grant that, sorry again. Yeah. Okay, so a consequence of this change of perspective, meaning reversing the semantic order of explanation, consequence of taking this step, I apologize. The consequence of this change of perspective is that from an epistemological point of view, the prescriptive structure does not share the same status as the empirical claims. Insofar as the prescriptions constitute meanings, they define the conceptual framework in which empirical questions can be formulated. In this sense, there exists a level of prescriptions that cannot themselves be refuted by experiments, at least not in any straightforward way. And I think the uncertainty relations somehow, or more precisely the prescriptions that derive from uncertainty relations, belong to this level of not really empirical principle. So let me draw a provisional moral. I'm not implying that Bohr would have been eager to interpret the uncertainty relation as Wittgensteinian rules of grammar, but still I think that the kind of Copernican turn that Koffer describes is precisely the direction towards which Bohr's reflection was heading. And now, one of the reasons for which I find it interesting to point out this connection, I mean, Bohr on the one hand and Wittgenstein on the other, is that the recent developments of the pragmatist trends inspired by Wittgenstein, the philosophy of language, have provided us with conceptual and formal tools which can be very helpful, I think, in making Bohr's philosophical intuitions more precise. In particular, one can dismiss the traditional representational account of propositional content in favor of a normativist theory of content. That is a theory which purports to capture the idea that the content of a claim is constituted by the prescriptions that govern its use in language. So let's grant that the normativist theory of content can accommodate the contextuality of value ascriptions that we need in quantum mechanics. That is, the fact that an observable can be ascribed a value only in a suitable context. This is my last point. Let's grant this. So, but then there remains the problem of stating the conditions in which it is appropriate to ascribe a value to a particular observable. That is, the conditions in which we should expect that objective talk concerning that observable, including the use of truth, is appropriate. The problem, as I have recalled at the beginning of the talk, is that quantum mechanics gives us no formal recipe to tell whether a certain context is realized. This is, if you want, the measurement problem. We don't have a prescription, an explicit prescription, which tell us when a certain context is realized, or when a certain measurement can be taken to have been performed. Now, within practice, there exist implicit norms that do authorize experimenters to claim that the result, which they believe has been recorded, has indeed been recorded. So, if a good experimenter comes and tells us that he recorded the result, nobody will put this claim into question in general. So, they claim that a certain measurement was performed and a certain result was observed is legitimate unless contrary evidence is explicitly exhibited. And if it were not so, there would be no physics. However, the legitimacy of this pragmatic rule is generally made to rest on implicit assumptions concerning the context. And the problem with this strategy is that when quantum contextuality is taken into account, we have a regress, because a context cannot be specified without making sure that the context in which that very specification is appropriate is itself realized, and so forth. So we have a regress, which is still another form of the version of the measurement problem. And now, here is where advocating a normativist theory of content can be useful. It is because a normativist theory of content allows a formalization of the pragmatic solution of the measurement problem that I just mentioned, which does not involve a regress. We are entitled by default to claim that ordinary macroscopic systems have the properties that we ascribe to them, but this default entitlement need not presuppose that certain truth conditions concerning the context are satisfied. Rather, default entitlement can be taken to be part of the very content of claims about ordinary macroscopic objects. In other words, someone who understands the claims in question ought ipso facto to acknowledge their legitimacy. To summarize, there exists a class of empirical claims that practitioners are allowed to treat as innocent until indicted on the basis of reasonable suspicion, as Robert Brandon aptly puts it. And this particular class of empirical claims, I think, are precisely Bohr's infamous classical statements, which describe the ultimate measuring instruments. Okay, I'm done. I can stop. I mean, once again, it is possible to show that this non-foundationalist way of accounting for the rationality of the prescriptions, particularly the prescriptions that we need to deal with the measurement problem, resonates with Wittgenstein's idea, particularly the ideas that he expressed in his notes on certainty that he wrote right before dying in 51, but I will not expand on this. And maybe I can just summarize what I wanted to point out. So the main reasons for which I chose to focus on Bohr's philosophy of language, and more specifically on his analysis of what characterizes rational practice in general and the use of concepts. The first reason, which is probably the least controversial, is that I think that this is the most original aspect of Bohr's analysis of quantum mechanics. I guess we can agree on this. It is something that distinguishes Bohr sharply from his contemporary fellows, and it is also the aspect that most decisively contributed to make Bohr's thought virtually unintelligible to many physicists, including some of those who officially identify with his views. And I think this is the feature of Bohr's philosophy that ultimately is responsible for the overall obscurity that surrounded his views, and also for the fact that those who oppose Bohr, as a rule, could not grasp the peculiar perspective from which Bohr was arguing. And this was, I think, a major source of misunderstanding in the intellectual disputes of the 30s and 50s. Second reason is that I think Bohr's views, as I pointed out, were strikingly in tune with the philosophical avant-garde of his time. Sorry. And I think we can, I can very quickly conclude. So that was, in my view, the impressive resonance with the achievements, the contemporary achievements in the philosophy of language, the contemporary proposal that were being putting forth by Wittgenstein and others. And one point which for me is very important is that I think, especially because of the latest developments in, as I mentioned, the philosophy of language and pragmatist trends, the philosophy of language, we now have a quite complete and consistent formal and conceptual framework. And if we use this to try and make sense of Bohr's arguments, I think we get a remarkable reconstruction, which, as compared to other reconstructions of Bohr's arguments, I mean here rational reconstruction, I'm not implying that he was actually saying exactly what I... But I think that we can, when you use this particular theoretical framework of pragmatist philosophy of language, like Robert Brandom or Sellars, Dummett, then we really get something which is surprising in a way. We can really, in my view, make sense of what Bohr was trying to say, specifically in connection with the measurement problem. And so we get a coherent and quite formal reconstruction of these arguments. And then I would say the last reason for which I think this is interesting, although this is not relevant for historiographical purposes, is that there could be formal developments today. I think that following this line of interpretation, one can easily reformulate completely the problem of the construction of quantum mechanics. So not only try to dissolve the two things are related, by the way, because the current program of reconstruction of quantum mechanics, I think, doesn't really address the measurement problem. And using the kind of approach that I have tried to describe, one can, starting from the dissolution of the measurement problem, get a completely new approach to the construction of quantum mechanics, the construction of the structure of the rules and the prescription. Sorry for the confusion.
Okay, one quick question. Yes, please.
Oh, it's not a quick question.
Okay, comment. Yes. Or you're saying it's a long question?
I'll try to make it as quick as
Okay,
possible.
short would be good.
So it doesn't really concern language. Tell me whether you consider this a kind of relevant anticipation. So in 1911, at the first Soviet conference in Brussels, Poincaré doesn't give a talk, but he makes comments. And I think he says this. So imagine a two-dimensional phase space, harmonic oscillator, so ellipses or circles or whatever. And imagine a square of area H, Planck's H. I think Poincaré says, well, consider canonical transformations that can stretch this square in one direction. So imagine rectangles along the position direction, along the Q direction, or rectangles along the P direction. Well, in that case, it's not an experimental context that gives you position or momentum, but it's this or that canonical transformation, which gives you kind of position, rectangle, or a momentum rectangle. If you view that as a relevant anticipation of more than Heisenberg, Bohr, I would say.
It looks like a very deep question.
It was a question of the coffee break, I think.
I think it's very relevant.
Yeah, it would be a long discussion. I have a question. Okay, let me then pause us on that discussion. Thank you.